Welcome to this explainer. Today we're zeroing in on an absolute core developer mantra. Let the machine do the work so you don't have to repeat yourself. Seriously, if you've ever found yourself typing out the exact same lines of code over and over again, or just wrestling with these tangled, messy webs of conditional logic, well, you are definitely in the right place. We're going to break down exactly how JavaScript control statements can completely empower you to write incredibly efficient, dynamic scripts.
All right, so let's dive right into this. Here's our roadmap for today. First up, we've got the power of for loops. Then, making complex choices. Third, the do-while guarantee. Fourth, breaking and continuing. And finally, we'll wrap up with JavaScript logic and truths. Let's level up your control.
Section 1, the power of for loops. This is really the first essential tool in our efficiency toolkit, automating repetitive tasks. To actually automate those tasks, we've got to understand something called counter-controlled repetition. In plain terms, this is basically a technique where you use a control variable to tell the machine to execute a block of statements a very specific number of times. It is literally the ultimate solution to the grueling problem of manual coding labor. Now, to pull this off, you need a specific recipe. Every counter control loop requires these four must-have ingredients. First, you need a control variable, which is just the name of the variable tracking where you are in the loop. Second, an initial value, that's your starting point. Third, you need the increment or decrement, which determines exactly how that variable is modified every single time the loop cycles. And finally, the condition. This is the test for the final value that tells your script whether it should keep looping or if it's time to stop. And this brilliantly illustrates exactly how those four components interact inside the machine's brain. Just look at the logic flow here. We establish that initial value, like setting our counter to 1. Then we immediately hit a decision point, the condition. If it's true that our counter is less than or equal to 7, the machine drops down and executes the body of the loop, which, by the way, could be one statement or 50. Then it sweeps over to the right, increments the control variable, and feeds right back into that condition check. The very moment that condition hits false, boom, the loop ends. To see why this actually matters in practice, look at this cause and effect. We have a counter-controlled while loop setting our counter from 1 all the way up to 7. Now check out the browser output. We didn't have to manually write out 7 different lines of HTML to create those increasing font sizes. The machine did it for us. With just a handful of lines of code, we dynamically generated multiple HTML font sizes. Perfectly. Okay, moving on to Section 2, making complex choices. Because let's be honest, sometimes you aren't just counting numbers. You're handling multiple, complex conditions, and standard if-else statements can get incredibly messy. Enter the switch statement. This thing tests a variable or expression separately for each of the specific values it might assume. Think of it kind of like a train yard director. The director looks at the incoming train's destination and seamlessly routes traffic down entirely different tracks depending on that exact value. It's clean, it's targeted, and it utilizes an optional default case, just in case the train doesn't match any known destination, so it doesn't just crash right off the tracks. Following the logic flow here, the script evaluates the controlling expression and compares it directly to case label A. If it's true, it runs case A's actions. But look closely at what happens next. The break statement. This is absolutely vital. The break acts as an emergency exit, ensuring the program immediately leaves the switch statement the second a match is found. Because if you don't break, the train plows right through into the next case, which you almost never want. And right there at the very bottom, there's our default action, gracefully catching anything that slipped through false on every preceding case. Let's actually see this train yard director in action. If a user picks the number 2, our code jumps straight down to case 2, assigning specific HTML tags for an uppercase lettered list. Then it hits that break command and gets right out of there. The result? A beautifully formatted, dynamic HTML lettered list. We just provided different HTML structural tags seamlessly, all based on a single user input. Section 3, the do-while guarantee. We've looked at checking conditions before we loop, but what happens if you need your code to absolutely, positively run at least once before it checks any rules? Well, that is exactly where the do-while statement comes in. It's a repetition statement that tests the loop continuation condition after the loop body executes. So the crucial takeaway here is that by putting the check at the very end, you're providing a guaranteed first run of your action code, literally no matter what. Visually, here's what that guarantee looks like. Notice how we just drop right into the action block at the top. The machine executes the statements first. Only after the work is actually done do we hit the true-false decision diamond at the bottom. If it's true, we loop back up to the action. If it's false, we just continue on our merry way. The action always sits before the condition. And here it is in practice. We set our counter to 1, and we immediately tell the document to write an HTML header tag using that counter. So it writes an H1 tag. Then, and only then, do we increment the counter and check if it's less than or equal to 6. Because of this specific structure, this block effortlessly generates 6 sequential HTML heading tags right there in the browser. All right, section 4, breaking and continuing. When you're processing data, things don't always go according to plan, right? Sometimes you just need to manage unexpected data on the fly. For this, JavaScript gives us 2 distinct, seriously powerful tools, break and continue. The break statement causes an immediate exit from the loop entirely. It is your emergency eject button. The continue statement, on the other hand, just skips the remaining statements in the body for that specific cycle and proceeds right to the next iteration. It's basically telling the machine, hey, skip this one step, but keep the overall loop running. Think of it kind of like a skip track button on a playlist, rather than turning the music player completely off. Now, what's really interesting is how break behaves in a standard for loop counting to 10. Look closely at the code here. We have an if statement inside the loop, basically saying, if the count equals 5, break. In the resulting output, it prints 1, 2, 3, 4, and then just abruptly stops, printing broke out of loop at count equals 5. The loop never even got to 10. It was completely terminated. Compare that to the continue command. Here, our code says if the count equals 5, continue. Check out the resulting output. 1, 2, 3, 4, it skips the number 5 entirely, and then picks right back up with 6, 7, 8, 9, 10. It simply skipped the document write action for that one specific iteration, but allowed the loop to finish its full job. Section 5, JavaScript Logic and Truths. To truly master control statements, we have to understand the absolute rules of how JavaScript actually makes these decisions. Up to now, we've mostly looked at simple conditions, but real-world data requires complex decisions, which means combining multiple conditions to ensure several things are true or false all at once. We do this using logical operators, the double ampersand for and, the double pipe for or, and the exclamation point for not, which is also known as logical negation. The and operator, for instance, forces the machine to ensure 2 separate conditions are both true before it will execute a path. But here is where JavaScript gets really interesting. It doesn't just evaluate strict true or false Boolean variables. It actually converts almost any non-Boolean value into a Boolean truth or falsehood behind the scenes. You really need to memorize these rules. Any non-zero numeric value, the machine sees that as true. The exact number 0, that's false. Any string containing characters is true, while an empty string is false. All objects evaluate to true. Honestly, even an empty object is true. JavaScript is just weird like that. But a null value, or a variable you've declared but haven't put anything inside yet, those are strictly considered false. Knowing these conversions allows you to write incredibly concise, powerful conditions.
So we've covered the for loop's repetition, the switch statement's complex routing, the do-while guarantee, and the emergency overrides of break and continue, all governed by the strict rules of JavaScript truth. So my question to you is, how will you use these tools of efficiency? Look at your current projects right now. Where can you let the machine do the heavy lifting so you can stop repeating yourself and start writing smarter, more dynamic scripts? Thanks so much for joining me on this explainer, and hey, happy coding!